Okay, we have another integral. This one's from the Vienna Integration Bee, 2024, problem 44. We have the integral of ln x minus 1 over 1 plus ln x all squared, everything squared dx. Okay, this one looks like a lot of trouble. I think what I need to do, I don't really know where to start, so I think I just want to try to simplify it. What we have, at least we know we have in common ln x here and here. So what I can do with that is let's make a u substitution just for ln x, because then at least what's inside the square here is going to become simpler. Then if I solve for x, we have x just with log properties, x equal to e to the u. Take a derivative, and then for the dx value, we just get dx is going to be equal to eu du. So then we'll go ahead and substitute everything here. Let's see, this is going to become, we'll have u minus 1. This becomes 1 plus u squared. I think I'll change the order just because I feel like I'll write it as u squared plus 1. Then all of this is going to be squared, and our dx becomes this, so we're going to have this eu du. And then it's still pretty messy, but I'm thinking maybe we can do something here with the algebra. So since this term here is squared, what if I just square the numerator and see if we can do something with that? So if we just look at u minus 1 squared, this is going to become u squared minus 2u plus 1. I can reorder this and we can end up with u squared plus 1 minus 2u. I do that just to try to match this u squared with this u squared, because then when I put this back, we can get some cancellation. So let's see how this is going to work. We've separated off this u squared plus 1, but this is still squared in the denominator. So we're going to have a u squared plus 1 all squared. Then we'll take this, we're going to split these apart, right? So we'll have 1 that's going to be u squared plus 1. We need to distribute this e to the u into both these terms. So we'll distribute in e to the u here. And then for this minus 2u, we'll split this off into a separate integral. So we'll say second integral, we'll add it. I'll leave it like this. So we'll have this as minus 2u. We distribute in the e to the u here. And then we have the same denominator. And we'll have this, and we need this du. But then this is the cancellation we want. We can cancel one of these with one of these. And now this is starting to look kind of suspicious. Just forget about the e to the u. If looking at this and comparing to this, what if I take this, let's come over here, and I'll take a derivative. What I want to do is I want to write this as, bring it into the numerator, write it as u squared plus 1 to the minus 1, just so that we can use power rule, take the derivative on this. When we do that, first the minus 1 comes in front, u squared plus 1 to the minus 2, then chain rule here, that's going to create 2u for the derivative of the inside here. Putting this together, 2u times the minus 1, this is going to be minus 2u over u squared plus 1, and this is all squared. But then this right here, this is exactly what we have right here. So what it looks like is we can actually use reverse product rule on here, because what's going on, e to the u is always nice for this, because if let's call this our f function here, the derivative of this, f prime, derivative of e to the u, is just e to the u. And then if we put a label on this one, we call this function here g, or a g of u, well then g prime, as we found here, g prime is going to be right there. So let me just make a little more space and then we can finish this off. Okay, so we have our definition for the product rule right over here. And just again, this is going to match exactly what we have going on in here, but inside of this integral, which I put back together in one integral, by the way. So if you take this, if we're just integrate everywhere, now this part is going to match what we have here exactly. Because we're integrating here, we're integrating a derivative. The result of this is just going to be f times g plus c. And we already determined those values. Our f value is going to be right here, e to the u, and our g value is going to be right here. So then just coming down here into this area, we can say that this whole thing is just equal to our f times g. So this is going to be e to the u times this, which was just put together as e to the u over u squared plus 1. And then all we need to do is just back substitute in order to finish this off. So to do that though, when we plug in ln x, e to the ln x, that just reduces to x. And then here, we'll plug in ln x here. We're going to have ln x squared plus 1. And so for our final solution of this, we just get x over ln x all squared plus 1 plus c, and that's it. Okay, there you have it. Good one from Vienna 2024. Thanks everyone for watching. Have a good day.